This video is available on videogcsc.com. Question 11. ABC is a right-angled triangle. AC equals 6 centimeters, BC equals 9 centimeters. Work out the length of AB. Give your answer correct to 3 significant figures. Try to do this question now. If you get stuck, or when you get the final answer, resume this video and see if you got the correct answer or how to do the question. When I look at this question, right away I think Pythagoras theorem, the Pythagorean theorem it's called, which is what is used with right-angled triangles. What that says is that this side AB squared plus this side AC squared equals the third side BC squared. Just to explain this, an extremely easy way to do this question would be just to use your ruler. Okay, you need to work out the length of AB, just measure it with your ruler. However, it says over here, diagram not accurately drawn. It does that so you can't just use your ruler, so you have to display that you know how to do this mathematically, that you know the maths. So you need to do what I said before, using the Pythagorean theorem. This side here, the longest side in a right-angled triangle, it's called the hypotenuse, and although I wouldn't remember it that way, I remember it as the side opposite the right angle. Whenever you see a right angle, the side opposite that is called the hypotenuse. That's just the name for it. And the reason why I say the side opposite it and not the longest side in a triangle is because here it says diagram not accurately drawn, so sometimes the hypotenuse is not the longest side simply because they don't draw the triangle accurately. So I would remember it as the side opposite the right angle in order to get the question right in the exam. Okay, so the Pythagorean theorem, created by a chap called Pythagoras, he said that a squared, let's just do this, he said that a squared plus b squared, if you have no idea where any of this is coming from, I'll explain this in a second, equals c squared. Basically he said that in a right-angled triangle, this is a right-angled triangle, he proved that this was true. In every right-angled triangle, the sum of the square of the two other sides equals the square of the hypotenuse. So if you multiply the length of the hypotenuse by itself, that equals the other two sides squared and added to each other. So the sum of the square of the other two sides. So this is how it's written in your exam books probably. I remember this as h squared. A squared plus b squared equals h squared, so I don't confuse the hypotenuse. And a squared plus b squared is just the other two sides. So I'm going to do this using this now. When you see a right angle triangle, you can always do this. It's a very easy way to do it. So my side A, I'm going to call AB because that's what it's down here, AB. So AB squared plus the side AC squared. So I could write AC squared, but actually I know the length of AC, it's 6 centimeters. So instead of writing down AC squared, I write down 6 squared equals BC squared, and I know that BC equals 9 centimeters. So I'm going to, instead of writing down BC, I'm going to write down 9. So using the Pythagorean theorem, I know that side AB times itself plus 6 times itself equals 9 times itself. I don't know how long the side AB is right now, but I do know that AB squared plus 6 squared equals 9 squared. To find out my final answer, I want it to be something like this: AB equals and then some number. To do that, I need to get AB by itself. So I need to use a strategy to get to rearrange this equation up here, um, to rearrange it into something like AB equals and then some number on the other side, the length of that side. So to do that, first of all, I'm going to subtract this 6 squared to get AB squared by itself. So it's going to be AB squared. Actually, I can just copy this. Yeah. So it's just going to be AB squared. Oh, it's not as easy as I thought. Oh, it's really not as easy. There we go. So it's going to be AB squared plus 6 squared minus 6 squared, because I'm subtracting that 6 squared to try to get AB by itself, equals 9 squared minus 6 squared. And the reason why I'm doing minus 6 squared here is to keep everything equal. Basically, this expression here, AB squared plus 6 squared, equals this expression here, 9 squared. So to keep the two expressions equal, first of all, I take away 6 squared because I want to get AB by itself. I want to get AB equals and then the number. And so I'm subtracting, I'm doing the inverse, which is maths for opposite, using the inverse method. The inverse of plus 6 squared is minus 6 squared. And what I do to one expression, I do to the other in order to keep them to the both of them equal. So, because I want to know what AB equals. So AB squared, I just work it out. So 6 squared minus 6 squared is simply 0. So it's simply AB squared plus 0. And a simpler way of doing that, a simpler way of writing that is simply AB squared. So AB squared plus 0. Just get rid of that. So AB squared equals 9 squared minus 6 squared. So I will simply work this out. 9 squared means 9 times 9, and 6 squared means 6 times 6. So 9 squared is 81 minus 6 squared, which is 6 times 6, which equals 36. So AB squared equals 81 minus 36. So AB squared equals 81 minus 36, and that's 45. Okay, so I don't know, so I'm trying to find out the length of this side, AB. I don't know how long that side is, but I do know that the length of that side squared equals 45. I do know that the length of that side times itself equals 45. So I again use what's called the inverse method to try to get AB by itself, so I can get a final answer that looks something like this: AB equals. So I do the inverse of squared, and the inverse of squaring is square root. So I want AB by itself. At the moment I have AB squared, so I do the inverse of AB squared, which is the square root. So I do the square root of AB squared equals the square root of 45. The reason why I do the square root of 45 is to keep the two expressions equal, to keep everything equal. I've done the square root of AB squared to get just AB by itself, so I need to do this to get the square root of the other side as well, to keep everything equal. So the square root of AB squared, well, what is the square root of AB squared? The square root of AB squared is something that multiplies by itself to give AB squared. Well, another way of writing AB squared is AB times AB. So the number that multiplies for that is simply AB. The square root of AB squared is AB because AB times AB equals AB squared. That's what the square root means. So AB equals the square root of 45. Now you use your calculator to find the square root of 45. So your calculator might be a little different. On my calculator I put in 45 first. You might have to put in the square root sign first, the square root symbol. I do 45 first. On my calculator I have to check this inverse box. Your calculator might say something like shift on the top left, and then I press this x squared, x to the power of 2, and that means I'm doing the inverse of squaring, because I've checked my inverse, you might have to press shift, and I press this squared, and that gets the square root of 45. Yours might be a little different. You might have the square root symbol on your calculator and you would simply press the square root symbol and then 45, or you might instead have to do what I did, which is shift squared, or my one says inverse squared. And this is the answer that I get, 6.708, and then lots more numbers. You'd have fewer numbers, but the question says give your answer correct to 3 significant figures. Well, this is what we've just found. We've just found out what the length of AB is. Now we know how long the length of AB is, how long the line AB is, but we don't need to give all these digits. They only need it correct to 3 significant figures. The significant figures are the figures starting in from the left, so moving in from the left. So 6 is the first significant figure, 7 is the second, 0 is the third. So the first 3 significant figures here are 6, 7, 0, but we need to give this to 3 significant figures. To do that, we look at the 4th significant figure and we use that to round the 3rd significant figure. Just to explain what that is, the 4th significant figure here is 8 because it's 6.708, 1, 2, 3, 4. 8 is the 4th significant figure. If that figure is 5 or more, we round the 3rd significant figure up. If it is 4 or less, we leave the 3rd significant figure as it is. So the 4th significant figure, because we're rounding to 3 significant figures, the 4th significant figure is 8, which is greater than 5, meaning we round the 3rd significant figure up. So instead of it being 6.70, it's going to be 6.71, because 8 is greater than 5 and we're rounding up. So our final answer is AB equals 6.71, and in brackets I'm going to write down 3 significant figures, because it isn't exactly 6.71, but the length of AB is 6.71 to 3 significant figures. Let's check the mark scheme and see if we got this right. 9 squared minus 6 squared, that's what we did. 81 minus 36 equals 45. The square root of 45, yep. The final answer is 6.705 to 6.71. So if you got that, I got 6.71. If you got that, give yourself 3 marks. Give yourself 1 mark, and this is why it's important to show you're working, because you can still get marks even if you get the final answer wrong. Give yourself 1 mark if you wrote down 9 squared minus 6 squared, or 81 minus 36, or 45, or 9 squared equals AB squared plus 6 squared, or equivalent. If you have any of those written down somewhere, not as your final answer, just somewhere, anywhere, give yourself 1 mark. Give yourself 1 mark if you've written down the square root of 81 minus 36, or the square root of 45. Give yourself 1 mark, and give yourself full marks if you've written down anything between 6.705 to 6.71. I've written down 6.71. Oh, and there's 1 mark here if you've if you've written down the square root of 81 plus 36 instead of the square root of 81 minus 36, or if you've written down the square root of 117, which is 81 plus 36 here. If you made that mistake, you would still get 1 mark. This is why it's important to always write down your working. The text solution to this video is available on videogcsc.com.